Some of the data gathered by astronomers points to the possibility of a new, potentially habitable planet. The closest star to the Sun, besides the Sun itself, has a planet named Proxima b that orbits it. Like our planet, this one is largely made of rock and can store water. Proxima b's orbit around this star, Proxima Centauri, only takes 11 days. Despite the fact that it's just slightly larger than Earth, scientists have only recently discovered this planet, and using large telescopes, they have begun to investigate it in greater depth, concluding that it may be capable of supporting human life. This was figured out because Proxima b orbits a cool red star that does not emit as much heat as the Sun. Stay with us till the end of the video. There's a lot of information to be revealed. Unlike gas giants like Jupiter, the stony terrestrial surface of Proxima b makes it take 11.2 days to complete one circuit around its star. With an orbital distance that's only 5% of the distance between Sun and Earth, Proxima Centauri is in a relatively close orbit around the star. When they are together, they get closer to each other than Mercury does to the Sun. As Proxima b's star is far cooler and fainter than our Sun, liquid water can exist on its surface without evaporating. If the planet had an atmosphere, scientists estimate its surface temperature would range from 86 to 104 degrees Fahrenheit. In the absence of air, temperatures can drop around -22 degrees Fahrenheit. Earth's temperature, without its atmosphere, is estimated to be -4 degrees Celsius. Due to its proximity to its star, Proxima b is 100 times more exposed to UV and X-ray outbursts than Earth is to the Sun's. In the past, they estimated to be 400 times stronger, but new information has caused them to reevaluate that figure. There's no way to predict the precise effects of this radiation on Earth's biota, but they will be felt. Based on our current understanding, Proxima Centauri b does not orbit its parent star on a regular basis. Because it does not seem to transmit in front of Proxima Centauri star when people focus from Earth, Proxima Centauri b is invisible to us. Because of this, it is difficult to estimate whether Proxima Centauri b has a roughly circular orbit or a highly elliptical one. If Proxima Centauri b were tidally locked with its star and didn't spin, then the same side would always face the star. If Proxima b Centauri is tidally locked, its day side would be too hot for liquid water to exist, drastically reducing the planet's chances of being habitable. Unfortunately, they did not make it through the night on the other side. If Proxima Centauri managed to hang on to a significant amount of atmosphere, airflow during the day's twilight hours might create a habitable zone. It's unclear if a tidally locked planet around a red dwarf star would be able to maintain an atmosphere. A highly eccentric orbit could mean that Proxima Centauri b is not tidally locked. There'd be a higher probability that it would become habitable if that were the case. Strangely, there don't appear to be any extraterrestrials nearby. This has long baffled researchers. According to our best estimates, there should be a lot of life out there. In addition, a sizable fraction of these aliens have to be technologically advanced enough for humans to come into contact with them, or at the very least, pick up on their radio conversations. There doesn't appear to be any life in the sky, and we haven't found anything outside of the norm yet. A new study, however, has revealed some intriguing results. It's possible that we were focusing our efforts elsewhere. Instead of trying to decipher the radio communications, we may search for evidence of alien urbanization. It seems impossible to see such dim lights from so far away. Then again, does it make sense to proceed? This study findings verify those of an earlier study by Avi Loeb. There are now more possibilities for astronomical research than we could pursue thanks to the James Webb Space Telescope. This telescope can image faraway worlds like exoplanets, when most others can only infer their existence. Light reflected from the exoplanet's surface can be detected by the James Webb Telescope, but it's not yet enough for high-resolution image. Before the James Webb Telescope was ever built, Avi Loeb saw its potential for spying on other civilizations. He figured out everything in relation to Proxima b, which is the exoplanet that most like Earth. Photos taken from various orbital phases reveal both of the exoplanet's day and night sides. This will allow us to compare the actual brightness to our expectations, with any discrepancy likely being the result of artificial light from an alien civilization. The key question is, how sensitive this approach will be. In order for the James Webb Telescope to discover exoplanets, their night sides must be heavily populated, emitting light at a rate of at least 5% of the light from their day sides. The amount of light emitted by our cities at night is only 0.01% of what is emitted during the day. The quirks of modern telescopes, built for spectroscopy, mean that the James Webb Telescope would only be able to detect 0.01 illumination if the city lights on Proxima b were 1,000 times narrower than the star. How wonderfully James Webb performed beyond our expectations! It is possible that the spacecraft will detect much less light or see the same on more distant exoplanets, suggesting that the current estimates are conservative. But a fascinating discovery was made as a result of this most recent inquiry. Thanks to the fact that the data needed for this method can be collected from other observations already planned for the James Webb Telescope, we can conduct this groundbreaking research at no extra cost. That settles it. Using cutting-edge technology to search for extraterrestrial life won't break the bank. Moreover, the study argues that the broader astronomical community must take the search for technical signatures seriously. You should know that SETI, the Search for Extraterrestrial Intelligence, has been looking for signs of extraterrestrial life for decades with little luck. Consequently, many eminent astronomers are skeptical that aliens live in regions surrounding any of the exoplanets that James Webb may survey in this way, since we should have previously picked up on their radio signals. But this is based on the highly speculative idea that alien society is compatible to our own. The research suggests that we keep looking even if we do not expect to find anything. An entirely new era of the study of the cosmos has begun. Even if we don't locate any alien city, our exploration of these distant worlds will yield invaluable information. Finding out why there doesn't appear to be any communication with other worlds would be a huge step towards resolving one of the largest mysteries in the cosmos, even if we don't locate aliens. Then, perhaps a significant breakthrough is just around the corner. Interesting facts about Proxima b. Although it is the closest star to Earth, Proxima b is so faint that only a very powerful telescope can reveal its faint light. When Proxima b suffers a solar flare, its brightness could increase by as much as 70 times. Its magnitude is only reduced to 7, still below the threshold at which the human eye can detect it. The density of Proxima b is between 2.5 and 3.5 times that of solid gold, and 50 to 40 times that of water. The red dwarf star is known for its extreme density. Proxima b has a mass 120 times that of Jupiter, but is just 1.4 times as broad. The star Proxima b will continue to shine brilliantly in the night sky for another 4 trillion years after our sun has died and cooled to a cinder. In 2016, a planet was discovered circling the star Proxima b with a mass around 1.2 times that of Earth. A star that far away is conducive of supporting life like that on Earth. Thank you for watching. If you have any questions, let us know in the comments section. Also, at last, give a like to this video. We'll see you soon.